Good afternoon. I'm here to do a demonstration about creating a single sample t-test um, statistics page using a given set of data and then to analyze the data. I'm going to share my screen. Okay, so I have created a spreadsheet already. It's out of the way. So the first thing that I did, of course, was create a descriptive statistics table using my reading data inside of my descriptive statistics. And then the descriptive statistics, of course, you go to data. You go to data, data analysis. You're going to find descriptive statistics. You're going to click OK. And then you're going to fill in your input range. Of course, you're going to click label and row. My input range was the reading scores. And then I chose an output range in order to place it to where I could see it. I click summary statistics, and then it gives you your descriptive statistics table. From this descriptive statistics table, I can see my mean, my standard deviation. Of course, the average that we're comparing the student average to, and the student average is 7.3. And then, of course, our count, which we're going to need to calculate the degree of freedom. And at this time, the rest of the information we don't need to calculate. The next thing, so in creating the six-step hypothesis steps was to review the population from the data sample, and the population are third grade readers. Question to be researched is, do third grade students' average reading scores differ significantly from the passing benchmark of 75? Given this data set, there was no other type of research question to come up with, and so it's pretty straightforward. The second step is to state the null hypothesis. And the null hypothesis is that the third grade students' reading scores do not differ significantly from the passing benchmark of 75. And then to state the alternative hypothesis is that they do differ significantly, either above or below the 75. When considering a hypothesis, you have to consider the significance of differentiation. So that third step is to set the percentage of significant difference. And then I'm going to use the 0.05 or 5%. And I'm getting that from the critical values table for the two-tailed t-test or two-tailed test. The degree of freedom, which is the sample size minus 1, gives us 9. The sample size is 10 minus 1, 9. And then I'm going to go onto that table. And if you see, I have the table here listed that if you go to your percentage of difference, compare it to your sample size, you come up with 2.262. So then your next step, 4, is to calculate the test statistics. So first you're going to create a descriptive statistics, which I have created on my spreadsheet. And then you're going to get your t-test statistics. So I use the formula that is on the screen where you have M, the capital letter M, which is the mean of your class average, your benchmark, which is 75, and here is your benchmark. And then you have your sample standard deviation and sample size. So which would be M minus the mu divided by your standard deviation square root of the sample size. And that is calculated here. And you get negative 0.416. So I also used the data tool in order to, I went to data analysis and I wanted to compare using the t-test paired two sample means, which I believe is next module, to see if some of my data would be the same. And you can see right here that it actually some of it is the same. So I have the degree of freedom, the t-stat score, which is here, and then I have the PT score, the critical score, and the PT2 score. It's not, let me see if I can make this bigger. I can read it. Ooh, yeah, let me see. There you go. That makes more sense. One tail, the critical one tail. All right. So step 5, we use the t-table and the significance level, 0.05 and the degree of freedom, which gives us a critical value of 2.26. And if the value of the test statistic is less or equal to 2.26, then we fail to reject the null hypothesis, meaning that the t-test, the test statistics, negative 0.416 is less than 2.62. So you can see that the scores do not differ significantly. They do not differ significantly from the benchmark, which is 75. So then we can actually use the Cohen-Dees formula to help us calculate how big the difference is in terms of standard deviation. And then I have the Cohen-Dees formula here. And we're going to calculate that. So equals parentheses. I'm going to use the mean minus the benchmark. Close it in with parentheses. Divided by our standard deviation. And I get negative 0.131. Anything below 0.2 tells us that the difference is so small that it just gives us no meaning. It supports the belief that the average scores and the district average has no significant difference. So it really just gives your initial evaluation credence in that the scores do not differ significantly. Going further, we can look at the R squared effect. I mean, these calculations are meant to give us the ranges of effect or differences of effect. And so then we're going to look at the R2 effect in equals parentheses, my t-score squared close it in, divided by my t-score again. squared. Maybe I'm doing this right. Close it in. Oop. Plus 9 and not sure I did that correct. Um, let's try it again. So formula, I'm going to have my t-score. T-score, t-score. All right. Equals, nope, equals, parentheses, my t-score squared. All right. Divided by my t-score squared. Nope. Plus 9? No. What am I doing? Mm, 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 mm. Well, we're going to try this one more time. Equals my t-score squared, which is shift 6 squared, close in that parentheses, divided by, I'm going to add parentheses this time, my t-score squared again. Oh, close it in, plus 9. I'm not sure what I'm going. I'm going to have to go back and I don't want to waste any more time. Um, in essence, the R squared formula was meant to give you another way to support your rejection of the null hypothesis. I'm going to go back and investigate what is going on with that. But there you have it. I did use this just to see if it would support any more of my information. Um, I still had to do the calculations. I thought this would keep me from doing any calculations, but it did not. And so there you go. All right. Thank you so much.